Okay, today we're talking about solving trigonometric equations. Equation being different from the identity in that it only holds true for certain values. Our identities that we've talked about the last 2 days, they're true for all values of x. Our equation only has certain values that are true and others are false. So they refer to that as conditional trigonometric equations. Now, before we start doing it algebraically, I'm going to point out to you how you can use your graphing calculator to help you. If we are solving this equation of y equals, excuse me, cosine of x equals 1/2, okay, you can go into your graphing calculator and you can put y sub 1 as cosine of x, and you could put y sub 2 is equal to 1/2, in which case you should have a graph that looks like this. Okay, this is solving the equations using your graph with something called the intersect method. I'm graphing both equations and I'm finding the points of intersection. So I'm looking for this point, okay, all these points of intersection. So hopefully you can see from that how many points of intersection do we have. We actually have infinite solutions because that sine graph goes on forever and ever. Okay, so you got to be aware when we're doing this, when you have, and it doesn't give you a specific interval, just tells you to solve, you have an infinite set of solutions where these things intersect, so our answers are going to be written like this, which is what we referred to earlier as coterminal angles. And instead of writing n as an integer, we're actually just going to use the symbols. N is an element of the set of z. Those are our integers. Okay, so some directions, if they say solve, your answers will look like that, according to whatever their period is. Okay, then you have other ones that are going to say solve over the interval of 0 to 2 pi. In which case, if I was only looking at this interval between 0 and 2 pi, hopefully you could see that you have one solution here and one solution there, which is what we have, x equal to pi over 3 and 5 pi over 3. So you just got to pay attention as we go through, and the first two I will check with the calculator. You can always check it by plugging back in, but that's something to know. The other method that I will show you on the calculator is one called the zero method, and I'll talk about it when we get to it. And those are, again, methods of checking it on your calculator because if you're interested in knowing whether or not you got the right answer and you don't have the book to look at, i.e. on the quiz and the test. So, to start off with, we're going to solve a trigonometric equation that involves only one expression, so we're going to begin by isolating the trigonometric expression, okay? And just like you've done with similar linear equations before, you want to get that trig function all by itself. So anything that's got a trig in it on one side, trig function in it, and anything that's not is going to be on the other. That being said, we're going to subtract 2 sine x from both sides of our equation, and that leaves me with 2 sine x equals, well, those of course cross out, the square root of 2. And to further isolate it, I got to get rid of that 2. That operation is multiplication, so I'm going to divide both sides. And so I'm left with the sine of x equals the square root of 2 over 2. So keep in mind, what you got to remember is your unit circle, because at this point you're asking yourself what angle has a sine of square root of 2 over 2. Okay, we are looking for an angle when we're solving the equations like this. So, referring to your unit circle, the angles that I get are pi over 4 in the first quadrant, and sine is also positive in the second quadrant. Same reference angle would be 3 pi over 4. But as we said, we don't have any specific restrictions, so that means that I'm going to take each of those angles. The period of my sine function is 2 pi, so I'm going to take each of those answers pi over 4 and add 2 pi n. And then 3 pi over 4 plus 2 pi n. That gives me all the coterminal angles, and I do need to say that n is an element of the integers. And we have solved that equation. Now, let's look at what that would look like on our graphing calculator. So I have it put in my calculator. All right, this is, as I referred to in the first example, the intersect method. So I took the left side of our equation and I put it in my calculator. It's F1. Yours, it would be y sub 1, either one. But for one of them, you're graphing the left side of your equation. On the other side, you're graphing the right side of your equation. And our answer we had was pi over 4. So when you look at where these two intersect, okay, and actually I can put that equation on there of that actual graph. I'm going to show you real quick. If I come in here and on an Inspire, I can actually type in x equals, our answer that we had on the from the problem was x equals pi over 4. And on an Inspire calculator, if I type that in, get out of my text mode, then I can come and drag it to the axes, and it graphs that equation for me. So if I follow x equals pi over 4 up, then I can see that is my point of intersection. That's halfway between 0 and pi over 2. Again, the intersect method, and I'm just checking my answers, and I can see that it's happening an infinite amount of time. Okay, so let's go back and do the next problem. All right, this one, another strategy that we might have to solve would be to take the square root of each side. Okay, we're still going to isolate it. Okay, so I'm going to move my 4 over. I have 3 times the cotangent squared of x is equal to 3. Got to divide by 3 because I'm trying to get this trig function by itself. And now I'm going to take the square root of both sides. And when I do that, I'm going to remember that plus or minus. So the square root of 1 is 1. So, and when I take the square root, I've got my plus or minus. Now, when you have these reciprocal functions, okay, you want to remember to take the reciprocal of both sides. So whenever you get down this far with a trig function, you're going to do that to both sides of your equation. So the reciprocal of the cotangent is the tangent, and the reciprocal of 1 is 1. So we're down to where's the tangent of x, where's the tangent equal to plus or minus 1. Okay, now our first angle, our tangent is equal to positive 1 at pi over 4, and it's equal to negative 1 at 3 pi over 4. And we know that the period of our tangent function is pi, which is how we get the first quadrant and the third quadrant, second quadrant and the fourth quadrant. So when we write our final answer, we have pi over 4 plus pi n, and then we have 3 pi over 4 plus pi n, of course where n is an element of the integers. And if we look at the graph, then we have, we go to the next page. Okay, this is a different method. What I did this time, if we look back at our equation, I went ahead and it's called the zero method because you set it equal to 0. So if I had subtracted 3, I would have 3 cotangent squared of x minus 3 equals 0. Okay, 3 cotangent squared x minus 3 equals 0. And so that means in my calculator, instead of a 0, I put it equal to y sub 1. Okay, that's what I've done here. And this is my zero method. And when you use the zero method, I like it a little better because then you're just looking for this point of intersection. Okay, you're trying to figure out what that is. And if you want to check, again, what we did is I had menu, I put a text, that is not the right thing. I put menu, I want text, and I typed in x equals, what was our answer? Our answer was pi over 4, so we're going to take pi over 4 again. I hit enter, I hit escape to get out of the text menu, and then I just drug it to the axes, and you can see that's where my point is. And you can look at your table also. But it's just a nice, quick, easy way to check your answers as you're going along. Okay, next example. I missed it. It's supposed to be example 3. So it's down at the bottom of the page. Okay, notice this time that our interval to solve over is from 0 to 2 pi. And we know from the bracket that that includes 0, and the parentheses means we do not include 2 pi. So if we have two answers, we need to be aware of that. So this time we're concentrating on another strategy, and sometimes you might need to solve by factoring. Find all solutions of each equation on the interval 0 to 2 pi. So whenever we're going to factor something, we're using that zero product property. So the first thing you always want to do is set the equation equal to 0. So I'm going to bring it all to one side. 2 times the sine of x cosine of x equals, nope, I'm supposed to set it, minus the square root of 2 times the cosine of x equals 0. Okay, hopefully you can see that we have a common factor in both terms there, cosine of x. So if I take the cosine of x out, then I'm left with 2 times the sine of x minus the square root of 2. Our zero product property says when you have two things that multiply to give you 0, either one of them has to be equal to 0, or the other has to be equal to 0, or both of them. So we take that in and we solve it. Cosine of x equals 0. And that tells us that x equals, where's the cosine 0? Hopefully you know from unit circle that's at the top and the bottom. So that would be pi over 2 and 3 pi over 2. And this one we have to go a little further with it, and now we're at that point where we started, we got to isolate that. So that's 2 times the sine of x equals the square root of 2. Sine of x equals the square root of 2 over 2. And where does that happen? That happens at pi over 4 and 3 pi over 4. Okay, again, you should check with your calculator to get used to doing that, or plugging it back in, whichever one you like better. Okay, next, let's go with 4 cosine squared x plus 2 cosine x minus 2 square roots of 2 cosine x equals 2. That one looks interesting to say the least. I do notice that these two both have a cosine. So when I bring this guy over, okay, I'm going to actually factor out so I can just look at it better. Um, or not, actually. This might be better for y'all. Let's do this. They do have a common cosine, but if I take it and I have 4 cosine squared x plus 2 cosine x minus 2 square roots of 2 cosine x minus the square root of 2. Okay, just like we've done before, or similarly, okay, if we group those two terms and these two terms, what do these terms have in common? Okay, hopefully you can see they both have a cosine of x. Actually, they both have a 2 cosine of x. So what am I left with? I'm left with 2 cosine x plus 1. And what do these have in common? They have a square root of 2. And generally when you do by grouping, you want to keep whatever that sign is. So that means I'm factoring a negative out. So I'm going to have 2 cosine x plus 1. Okay? And remember, when you factor by grouping, okay, if these two terms are not the same, then you're not going anywhere with your factoring. Okay, so you might reorganize your terms. But now I have those two in common, so I'm going to take that out. 2 times the cosine of x plus 1, and that leaves me with 2, I'm sorry. Yeah, that's right, right. 2 cosine x, because I took out the common factor. So the common factor is 2 cosine x plus 1. I'm left with 2 cosine x minus the square root of 2. I have a product equal to 0. I'm going to set each factor equal to 0. 2 cosine x minus the square root of 2 equals 0. Isolating my trig function leads me to 2 cosine x equals negative 1. Cosine of x equals negative 1/2. So x equals, where's the cosine negative 1/2? 2 pi over 3 and 4 pi over 3. That's the pi over 3 angle in the second and the third quadrant. And over here, I'm going to have 2 cosine x equals the square root of 2. Cosine of x equals the square root of 2 over 2. Cosine is positive in the first quadrant at pi over 4 with that value, and then in the fourth quadrant at 7 pi over 4. So there we have it. Again, check on your calculator if you want to make sure you have the right answer. Practice before you take your quiz on Tuesday. Okay, real world example. So from here, we got a baseball, leaves the bat with an initial speed of 30 meters per second, clears a fence 90.5 meters away. The height of the fence is the same height as the initial height of the batted ball. If the distance the ball traveled is given by this formula, right here, this wonderful formula, which is the hardest part of these problems, where 9.8 is in meters per second squared, find the interval of possible launch angles. So they're asking us for this angle right here, okay? What are the possibilities for theta so that it will clear the fence? So what we need to do is set 90.5 equal to our distance, and that's going to be the initial velocity squared, which are initial speed. They told us that was 30 times the sine of 2 theta all over 9.8. Okay, and you know me, I don't want to pick up my calculator till the end, so I would solve this by multiplying both sides by 9.8. That would get rid of this, but now I got to get rid of that, which means I'm going to divide by 30 squared. And that's equal to the sine of 2 theta. Okay, keep in mind, this is the sine of 2 theta. We're looking for this angle that has that sine value. Okay, if you plug this in your calculator, whichever way you want to go, with that number, we're going to get a number that is 0.9854. Okay, that's what this expression equals. So what does that angle have to be? So if it has a sine value of that, then that means that the angle, you're going to do inverse sine on your calculator, and your calculator is going to give you a number of 80.2. Okay? Remember, we've talked about where's the sine positive. So you've got 80 degrees up here. Okay? This angle right here is 80 degrees. I also need the one in the second quadrant because the sine is positive over there, where this is 80.2. Right, 0.2 on both of those. So, of course, how do we find that? We subtract from 180, and we will get that it's going to be 99.8. So that's the angle, but keep in mind that angle was 2 theta. So how do I actually find out what theta is I have to divide everything by 2. And at this point, 2 divided by 2, of course, is the 1 theta. Divide that number by 2, and you have 40.1. And divide that one by 2, and you're going to get 49.9. So to answer the question, the interval that the angle has to be, the smallest would be 40.1 degrees, and the largest would be 49.9 degrees. And that is the interval of theta that we need. Okay? Moving right along, we have just a few more. This time we are going to use what we talked about yesterday. and the day before, we're actually going to have to plug in some identities to help us solve problems. Okay? Now, when you're doing these problems, 1 minus cosine x equals 2 sine squared. Okay? We have no substitutions for cosine of x. We do have a substitution for the sine squared. Okay? Our basic trigonometric identity tells us that the sine squared of x plus the cosine squared of x is equal to 1. So if I need to substitute for sine squared, it's going to be 1 minus the cosine squared. So 1 minus the cosine of x equals 2, and my sine squared is 1 minus cosine squared of x. So we have to distribute that. 2 minus 2 cosine squared of x. And I am at your typical quadratic equation. So at this point, we need to bring everything to one side, and I want my squared term positive. So I'm going to bring it over to the left side. 2 cosine squared x minus the cosine of x, and then 1 minus 2 is minus 1. Okay? Now, to go on something that we did before, you might remember, okay, we did this with our exponents. Let u equal the cosine of x. If you have any trouble with this, you might consider it. That means that 2u squared minus u equal, excuse me, 2, 2u squared minus u minus 1 equals 0. Then factor that. 2u and u, which one has to be negative? I need a negative u, so this one. So it's 2u plus 1, u minus 1. And then we set each of those factors equal to 0. Now, at what point you do this does not really matter, but at this point, I'm going to go ahead and put my sub back in there. So that means that 2 times the cosine of x plus 1 equals 0, and the cosine of x minus 1 equals 0. Now, some of y'all can go from here to here, factoring without any trouble, and if you can do that, I'm all for it, okay? So this tells me that the cosine of x is equal to 2 cosine of x equals negative 1. Cosine of x equals negative 1 half. So that means x equals, where's cosine? We just did that. That's 2 pi over 3 and 4 pi over 3. Because I checked in our problem here, they asked us to solve it over the intervals, so I don't have to give all the coterminal angles. And on this side, I have, tell me where the cosine of x is equal to 1, and cosine of x is equal to 1 at 0. So there we have it. Again, check on your graphing calculator. Easy to do. Okay, this next one, cotangent squared, cosecant squared, 2 cosecant squared, cotangent squared. There's a lot in there. So I think what might be best is to look at this problem, look at it from the standpoint, if I let u equal the cotangent squared, there's another cotangent squared. And then v equal the cosecant squared. Then I have u times v plus 2v minus u equals 2. And I'm kind of going to do this. And so I'm going to bring it together. uv plus 2v minus u minus 2 equals 0. It doesn't look as scary like that as it does like this. So from here, I am hopefully going to group these first two terms and these last two terms. They have something in common. They have a v, leaving me with u plus 2. And that looks like u plus 2, and it will be that way if you take a negative 1 out. U plus 2. You can see negative times positive u is negative u. Negative and positive 2 give me negative 2. So we factored that out correctly. And now I have a common factor. So I'm taking out my u plus 2, and that leaves me with v minus, hopefully you said 1, equals 0. Okay, so I have each factor, u plus 2 equals 0, v minus 1 equals 0. Okay, at this point, I'm going to go back. What did u and v stand for? U was the cotangent squared of x. and v was the cosecant squared of x. So this tells me cotangent squared of x equals -2. Yippee, not possible, so I don't have to worry about that because I can't square something and get a negative number. Over here, cosecant squared of x equals 1. All right, we talked about that earlier. That's one of the reciprocals, so I'm going to take the reciprocal of that, which is the sine. So the sine squared of x equals 1 because the reciprocal of 1 is 1. Take the square root of both sides. If I do that here, and that leaves me with the sine of x equals plus or minus 1. So where's the sign positive and -1? At pi over 2 and 3 pi over 2. Okay, keep in mind, just like anything you've done up to this point, there is more than one way to solve these equations. This is just giving you some ideas, and you're going to get better by practicing and practicing. Okay, the last example that we have, last two examples, don't want to mislead you, is to solve by squaring. Okay, yet another strategy. So when I look at that, because I don't really have any substitution, I mean, again, there's more than one way to do it, but this is just one of those strategies you try. So I'm going to square both sides. And when I square this side, I'm going to get, that's a binomial squared. So I get secant squared x plus 2 secant x plus 1 equals tangent squared x. Now, if you don't know how I got that, you might have forgotten that a plus b quantity squared is equal to a squared plus 2ab plus b squared. So that's what we've done. Now, whenever you're thinking about making any kind of substitutions, you need to keep in mind that whatever is the one, we've talked about this without the exponent, that's the one you can't change. So you have an identity with secant and tangent squared, okay? Over here we had sine squared x plus cosine squared x equals 1. If I divide everything by the cosine squared, sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. 1 over cosine squared is secant squared. And I tell it to you like that, so hopefully it'll be easier for you to remember it. So you can substitute for either one of these, but if I can't change this, I need everything in terms of secant. So I'm going to make a substitution for the tangent squared. So that gives me secant squared x plus 2 secant x plus 1 equals, what is the tangent squared equals? It equals secant squared minus 1. So that's what we're going to write here. Secant squared x minus 1. Well, how nice. My secant squareds fell out this time. So I'm left with a single trig function. So I'm going to take that 1 over there. 2 secant x equals -2. The secant of x equals -1 because I divided by 2. Again, reciprocal. The reciprocal of the secant is the cosine. The reciprocal of -1 is -1. And where is the cosine -1? Is at pi. Okay? Last example. Cosine equals sine minus 1. I'm going to do the same thing. Okay? And that's going to give me cosine squared x equals sine squared x minus 2 sine x plus 1. Okay, which one do I have in there that doesn't have an exponent is the sine function. So that means I'm going to go substitute for the cosine. And that means cosine squared equals 1 minus sine squared. So I have 1 minus sine squared x equals sine squared x minus 2 sine x plus 1. I have a plus 1 and a plus 1 on both sides, so that'll go away. If I add, because I want it to be positive, then I'm going to have 0 equals 2 sine squared x minus 2 sine x. I have two terms, and those are simplified or excuse me, factored by first looking for a GCF, which I have a 2 sine x in both of them. What am I left with here? I have um, sine x minus 1. So we set each of these equal to 0. 2 sine x equals 0. Sine of x minus 1 equals 0. This leaves me, divide both sides by 2. 0 divided by 2 is 0. So where is um, sine equal to 0? And that happens at 0 and pi. And over here, this says the sine of x is equal to 1. Where's the sine equal 1? Is it pi over 2? Okay, here's a good example. If you go to the graph, second, okay, which method did I use? If you look at that equation, hopefully you can see that I took the equations and brought them all to one side. So I'm using the zero method. I like the zero method because I think it's easier to find those zeros. And on our problem, we had it at 0, pi, and pi over 2. So if we go back and look, is there a 0 at 0? No. Is there one at pi over 2? Yes. And is there one at pi? Yes. So actually, it turns out, and you can do it algebraically as well, that that doesn't check in our answer. So my answer is just x equals pi and pi over 2. Now, just real quick, coordinates of 0 are 1 comma 0. So that means this is the cosine and that's the sine. So if you think about that and go plug it back in, what you have in our equation is, does 1 equal 0 minus 1? And that doesn't work. I showed it to you on the graph, but you can also check it algebraically. So have fun solving your true equations. Come see me if you get stuck.